focusing on how to create a section drawing. Now, what happens is that you see a picture like this and you want to try to replicate it, right? And so you're thinking, well, how am I going to create this in 3D or isometric, or trying to develop it exactly the way it looks like in a textbook? But that's not our goal. The goal is to provide the representation of what you need to see through this cutout. This half section is what it's called. So a half section removes a quarter of the object. If it was a full section, it would have cut it straight in half. But they've only removed a quarter of the object itself, so we can see what the shape looks like. And now what we're going to do is replicate this in an orthographic style drawing. This again is something that a lot of people try to replicate. Again, trying to create that isometric and stuff. No. Can you do this in 3D? Absolutely. But that is not what our focus is. So let's go ahead and create this as a 2D object and develop the part. So we do our normal setup routine here. We first start with the units tool. And this is an interesting scenario because we have drawing utilities in our units. This happens to be metric. So what do? Okay, well, metric is still a decimal value, except it doesn't have any precision to it, because the millimeters are the smallest level of precision we're going to work with. So we can set the precision to 0. The angle will still set as decimal degrees, and we'll leave the precision to 0. The insertion scale, this is only if you're going to take this, make it a block or a W block and bring it into another object. We could set this to millimeters since that is going to be our base unit. And we'll choose OK. So that's set up our drawing units. Not our dimensioning units, but our drawing units. So now we also have some other setup items here on the bottom row. We've got the polar tracking, and we'll right mouse click on the polar tracking and choose tracking settings. And the tracking settings tell us what angles that we're going to be able to lock into. I usually set it up for 5 or 10 or 15 degrees. 45 means that we're going to basically lock 0, 45, and 90. If I do it at 10 degrees, it's every 10 degrees. If I do it at 5, it's every 5 degrees that it'll lock into place. Well, this object doesn't have any angles associated with it that you can tell by the drawing shape, so we can set it at 10 or 15 degrees and it should work out without a problem. We can definitely base it on our absolute positioning, which is the 0, 0, 0 location, and we're going to track orthogonally. We'll choose OK, but we can also set up our object snap at the same time by just clicking on the OSnap tab at the top. And again, I typically set up 6 object snaps as a standard setting, the ones that are most commonly used when you create a drawing: endpoint, midpoint, center, intersection, extension, and perpendicular. I don't set up tangent because tangent and center conflict with each other, and so I use tangent as a pop-up object snap. So that sets up our drawing parameters. Now we need to set up our layers. So we choose the layer properties, and as always, it's a good practice to set up several layers and not draw on layer 0. Just kind of leave layer 0 as a unique layer by itself. So we're going to go ahead and create a new layer, and we'll call this object. And we're going to have some hidden lines and dimensions. So I just hit the enter key twice to set up a new layer. We'll call it dimension and hidden and center. And it will alphabetize these. And I didn't type in, I must hit the enter key twice and center did not pop up. So I'll type in center here. Alright, so I got one extra layer, layer 1. That's okay if you have an extra layer in there. We might need it if we're going to do a calculation for area or develop a different shape or a different view, that kind of thing. We can use that layer. So things that I like to do with the layers is set up colors, so I know that the colors are oriented to the layer itself. I'll start with the object layer. Since my background is a dark black background, I want to use lighter colors, because if I use the darker colors, they're not going to show up. So I'm going to use the brighter, lighter colors. And so we'll pick an orange-ish color for the setting, and center is always green, and hidden will make this light blue, and dimension will make this light red. Very pinkish kind of color. Fusion. Alright, so we've got our layers colorized, so we know the different colors that pop up. The things that I do need is I need to have a center line and a hidden line, and we need to change those line types. So I'll pick the center line type, which is currently set as continuous. We don't have any extra line types created, so I need to load them. So now this happens to be a metric drawing. We could use the ACAD ISO settings, which are metric scaled line types. However, I still default to the line types with the names. So in this case, we'll choose center lines to load. And if I play this right, I can scroll down a little bit farther and find hidden. Now the trick is to select both at the same time. I have to hold the control key down on my keyboard. So if I hold the control key down and then select hidden, release the control key, I can now have hidden and center both selected at the same time. So that little control key allows me to add to my selection set. And I'll choose OK. You can see now center and hidden are now loaded to my list. And I can select center since that was the line type that we were selecting. We'll choose OK. I'll do the same thing for hidden. I'll click the continuous, and now I can select hidden. Now you're going to think, and you're going to say, wow, well those line types aren't going to be sized or scaled for the metric drawings. That's okay. There are commands that help us to scale line types and dimensions. Line type scaling is the command that we're going to use, and dimension scaling is the command that we're going to use for this particular drawing. Alright, so we'll choose hidden. And so now we've got the line types set up with this. Now there's one other setting that you could do. It is optional, but it does make your drawing look better if you're going to utilize layouts, which is the line weight, and setting the object or the shape lines to a little bit thicker line weight. And the line weights are always in millimeters because that's what pencil lead is sized in those mechanical pencils, is millimeters. And so it's the same kind of line weight. You can do an 070 as a line weight, or an 050 is another common one. So you can pick your line weights based on what you're used to working with. This will not show up in the model drawing. This only shows up inside the layout settings of the drawings environment. So now we're set up with our layers. We've got our layers set up. Our current working layer will be, well, we typically start with the center layer to lay out all of our center lines. So we'll set the center line as our current layer. Double click on it. If you double click on the word, the little green check mark moves. I'll hit the X button to close the layer window. So now my center layer is what's being displayed here, and if we need to change it, we just use the drop down. So we're going to choose a line, and I'm going to draw a straight line. Straight across, arbitrarily picking the starting point. Alright, so we're going to draw a straight line. There it is. We'll stop the line and we'll hit enter. I'll then draw a vertical line. Again, arbitrarily locating that spot, and that vertical line will be the center point of our circle. So the diameter of this is 62, which means that it's going to be pretty large. So I better back out of the drawing shape. I need to kind of shift this over here because it's going to get in the way. So let's hit move. And we'll move this over, and we'll increase the size so you can see it again. So now we're going to create a circle, but the circle should be on the object layer. So we want to go ahead and pick object and make that our current working layer. I'll pick circle, and I'll pick the center point. Now the center point might be the midpoint, but it definitely is the intersection of the two lines. You'll notice that the midpoint is not on the center intersection, so I want to make sure that I pick the intersection. Now I just used my mouse wheel to magnify this. So moving that wheel on the mouse increases or decreases your magnification. I'll select that first spot, we'll bring it up, and we said 62, right? Yep, 62. So our 62 is still pretty big, okay? That's 62 units. Now some students will just guess and just draw a circle and make it seem like the actual drawing is accurate, but let's do this right. It's an accurate drawing, so we're going to have to move it out of the way, increase the line weight, and so forth. But I made one major flaw. I drew on that center line layer and it popped up or reset to center line. So I'm going to go ahead and grip it by picking it, change the layer to the object, hit the escape key, and that circle now changes back. I have to do the same thing, grip it and stretch the center lines here. So I'm going to pick the center line and stretch it so it goes outside, making sure that it stays horizontal, because if it's not horizontal, it will cause an issue in the future. So all I'm doing is picking the endpoints of these lines and extending them. If I hold the wheel down, I can shift my whole image up, called a pan, and there we have it. Now, granted, the center lines are really itty bitty small. So how do we make the center lines look better? Because we've got a really small drawing. Let's go ahead and move our object out of the way here, our drawing. And we'll shift it over here again and increase the size so we can see it. And so we've got the first circle drawn, the face circle here. How do we change the line types of the center lines to look better? So we're going to use the line type scaling. So we'll type LT scale. And I find it easier to type this one than trying to find it. So LT scale is the command, and I'm going to set it to 24 times. Now, if you think about it, the difference between millimeters and inches is 25.4. So 24, 25 should get us into the same, and if I set it to 25, we'll scale up. And notice what happens. It scaled up the line type 25 times, and now it looks more appropriate for the size of the drawing we're working in. And so that gives you that LT scale and that value, and again, it's the difference between English and metric conversion, can give you that particular setting. And you can do the same thing with architecture. 1/4 inch equals a foot is 48. 48 times does a 1/4 inch go into 1 foot. So you can use those scaling factors to manage the drawing line types and dimensions working forward. Alright, so now we've got the first circle drawn, and now we're going to draw the side view of this. So we've got the face view, and we can draw the other circles in. If you want to, you can go ahead and add the circles in, but we'll clean up that here in just a minute. I wanted to draw the side view to kind of get an idea of how big the side view will be. So to create the side view, we're going to start with a line command. And we know that the line starts from the bottom edge of the circle, right? So if we take that bottom edge of the circle and project it over, all I'm doing is I'm not picking, I'm just highlighting. And notice I get a construction line at the bottom. What that allows me to do, that's called the extension object snap. And so I'm able to take this and draw straight up. I'm still in the center line layer. Let's go ahead and change this to objects so that way we don't mess up on that. So I'll pick the line, highlight, do not pick, get the extension over, and pick a starting point. Well, the second height extension can bring over, and that'll give us the height of the shape. Now the thickness here is telling us on our drawing that it's 15 units wide. That's in the back part of the drawing. And so we'll draw this horizontal 15 units. And then it comes down, let's see here, the outer circle is 44 units. So 62 minus 44 is 18 units. And so that 18 units will bring us straight down. So again, we're working from the dimensions that are provided. So we'll come down 18 units. And the width between this is 100 total from end to end, but we subtract 30, 15 on each side. So if we do that, that leaves us with 70 units in the middle. So again, I'm pointing and I'm typing in the value that we're needing. We can then go straight back up 18 units, come over 15 units. So if you type, and as long as you don't hit the enter key, you can reposition to make sure that it's horizontal or vertical. And now I'm going to come back all the way to the beginning, all the way down at the bottom, and I have to do the same thing here at the bottom because it's the same shape, it's round. So that's 15, 18 up, 70 across, 18 down, and 15 across. Now I can just connect it, but it will also pop up and give me an idea of how long it is. But I'll connect it right there and right mouse click and choose enter. Now if this object doesn't look symmetrical, we have a problem. If these are off or it looks like there's one edge that's slightly different, then that means that you probably typed in a wrong value or your cursor wasn't exactly horizontal. So I'll grip this and slide this a little bit farther and hit the escape key. So now we have the side view. Now we have to remember that this particular side view is a half section. So we removed a quarter of it. So removing that quarter gives us two halves. So when we look at it from the side, we're going to see a solid line here. So if I were to be standing down where my cursor is now, down in the lower right hand corner, looking at it, I would see the line of the object, and then I would see the surface here, the shape of the surface on the upper part, but the lower part would still be solid, the outside of the object. So now I've got to draw the shape of the inside. Well, to draw the shape of the inside, it's actually easier to draw the circles first and then project it over. So we're going to do that. So the internal circle says that it's a 16 diameter hole through and a counter bore of 28 with a depth of 8. All right, so let's draw a circle. So this circle is going to start from the intersection, and we're going to say it's 16 all the way through. So the diameter is 16. But am I drawing the diameter or the radius? Oh no. You know what? I bet I drew that 62 on a radius and not a diameter. That happens. You mess up. So what do? Things are just totally messed up. If I were to throw a dimension on here now, I bet you it would say 128 diameter. Well, we couldn't see it, but we could zoom up, and sure enough, it's 124. Sorry, it was 124, was the double of 62. All right, so now what do? Oh no, do I start from the beginning again? No, we fix it. So sometimes that happens. You just mess up. And so you end up and you scale the drawing. So if I choose scale and I scale it down 50%, we should be fine. So I pick the scale command, window around everything, right mouse click, pick the center point, and then say I want to go 0.50, 50% the original size. And now I can move this over just a little bit more so we can see this. And maybe we need to shrink this now that it's a little bit smaller. There we go. Boy, that was a big mess up. But again, fixing it is not that difficult. All I did was, instead of putting in diameters, I put in radius values, or I thought the radius was the diameter and I didn't watch what I was doing. Common mistake. Common mistake. So you just scale the parts by 50% and now they're back to regular size. How can we tell? Well, I can go to the diameter dimension command, or I could use the properties command. If I grip this and I right mouse click and I choose quick properties or properties, either one, I'll choose quick properties. It tells me that the diameter is 62 now, and that's important. All right, phew, save that. Let's go ahead and draw the circle. Remember, we were doing the counter bore here. It's 16 through and 28. And I discovered that it was going to be too big. So 16, half of 16 is 8. So we're typing in the radius value of 8, and that's my 16 diameter. Now I have to do the same thing with the counter bore, which is a 28. So again, we're going to start from the intersection or the circle center. And this time it's going to be 14, half of that 28. All right, what makes this nice now is that I can draw and use construction lines to create the shape. Sorry, I'm just readjusting the image so you can see it again to make it easier. Okay, so now I've got my construction lines that I can project over to create the solid lines on this drawing and hidden lines. So I'm going to draw a line. The counter bore starts off from the front here and goes in how deep? 8, right? That's what it said? Yep, 8. So I'm just going to draw 8 units in. And then it's got to come all the way down to the bottom here of that counter bore. So I can project that and bring it across. All right, now that's not totally done yet, but that's a good start. We have the other hole that was 16 diameter. So I'm going to project over, and that projection is going to start at the base of that counter bore, and it's going to go to the other side. But we're going to be drawing a counter bore on the other side also, is what's going to happen. So in essence, I can run it here and I can trim it in a couple of minutes. All right, so I just drew the 2 lines projected from the inside circle across. So far, so good. Now I've got to draw another counter bore on the back end because you can see that it's the same shape counter bore on the back end. So I'll do the same. Project this over, pick it, come in 8 units horizontally, bring it down and project to the bottom and bring it out to the outer side. Now I've got these extra lines in here. I can use the trim command and I can trim these extra lines out. And while we've got the trim command live, theoretically I need to trim this line out too, because that line is no longer needed. Oh, I trimmed and I had like 2, or I didn't pick it right. There we go. So now we have our shape, and it looks kind of weird, right? We've got this shape on the out and we've got this shape on the inner. But it does look similar to the shape that you're looking that's shaded here. If you look at the shaded shapes, they have a similar kind of pattern in that development. Now remember, the top half we can see, the bottom half is the outside of the object. So the bottom half is going to be hidden lines. Whew. So if I pick the lines select them. All I'm doing is gripping them. And I change the layer to hidden and hit the escape key. It now changes the bottom half to the hidden lines, which is what I need. Because I can't see the inside shape on the bottom, but I can see the shape because we've cut the top. Now I also have to put in the hatch pattern. So there is a command here called hatch, and that hatch pattern command pops up a window, or pops up a new ribbon. And the first thing it wants me to do is pick a point. Well, I'm going to pick a point on the inside, but I need to pick a hatch style. And again, I can control the hatch with scaling because it gives me the ability to scale the hatch value, but I can also use one of the ANSI, which are metric scales. So I'm just going to use this ASNI 31, and I'm going to pick a point on the inside. Okay, so the ANSI 31 is still pretty dense. If you take a look, there's a bunch of lines there, but it's very dense. So I need to scale this. So what are we looking at? Well, here's the scale pattern. Remember, we used the scale factor of 25. If I were to type in 25 here, magically the hatch pattern looks much better, because we scaled it up 25 times the original size. So again, hatch, and let me do this again because I did it quickly. So we pick the hatch, and the hatch ribbon comes back up. The scaling factor is here on the bottom, and I changed the scaling factor to 25, which was the base of 25.4. Okay, remember, metric English conversion. So now I've got this view here. I've got the side cutout here, the side with the cutout edge. And realistically, I'm done drawing. That's it. That's all there is to it. Except I'm missing a hidden line on this view. And that hidden line is this edge, or this surface on the inside. And so that one is 44 diameter, or 22 radius. So I'm going to draw a circle from the center. Come here. There's the center. I'm going to draw it at 22. But I have to change this to a hidden line because I can't see this surface from either direction. So this surface is a hidden line. So now my drawing is complete. The bottom half of the shape is hidden lines because I can't see the inside. The outer half is solid lines. I can see the inside there. And so this is the shape on the inside of the hole with the counter bores. And this is the shape, the outer edge shape. And that's the surface that literally got cut by the saw, and it left the saw marks of the hatch pattern. The last step is to do dimensioning. And I'm not going to fully dimension this, but I'll give you a couple of examples. And I'm going to flip over to the dimension layer first, and we're going to do a diameter dimension on this outer drawing. So one of the things you need to think about is, where are the dimensions going to get placed? You know, it's very convenient to put the dimensions in between the objects, but if the dimensions get too crowded here, you're going to need to put it around the outside of the shape. So the first dimension I'm going to put is the outer diameter. Now you can barely see it. I mean, it's there, it's purple, it's pink, because we changed the color of the layer. But it's not the right scale. So there is a command called dimension scale, and there are settings for the dimension styles for dimension scaling. So I'm going to go ahead and show you how to do this. So we're going to pick dimension style, which is the paintbrush with the dimension. It's going to bring up a window, and we're editing the standard dimension style. So we're going to go ahead and modify it. And it brings up a bunch of tabs. Anything that you want to be able to edit in dimensions is highlighted in this area. Now what's interesting and what really messes people up is the primary units, which is great, is decimal, but I only want the precision to be 0. Because again, we're in millimeters here. So we don't need a setup of decimal units. So this allows you to set the precision under primary units. But then people get thrown off by measurement scale. Don't worry about that. That's not the scale or the size of the dimension. The scale and size of the dimension is found under fit. And so the scale for dimension features, let's type in our magical 25 because that's what we've been setting up. And if we wanted to make them true metric dimensions where it doesn't split and they rotate and so forth, we could set those values up on the text placement environment. We'll choose OK. So now the dimensions will look like this. We'll choose close. And look what happened to our diameter. It increased it increased 25 times, so now we can see it. So the same thing can happen here. I can do another diameter dimension, but this one I'm going to actually do it towards the bottom on this interior one. Why? Because we need to design a hole command associated with it. So if we're going to edit this dimension, I double click, it brings up the dimension text window here, and you can see I got a blinking cursor on the left hand side of the diameter symbol. Well, I actually am going to use my arrow keys and move it to the right hand side on the other side of the 16. And I'm going to type 16 through. Okay. Then I'm going to put a space, and then I'm going to find the counterbore symbol. So is there a symbol for counterbore? So I'm looking at the list, looking at the list, looking at the list. I don't see a counterbore symbol. Okay. At least not one that I can easily identify. So I can hit other, select other, and it's going to bring up a selection set of a character map. So this character map is this math symbols, and there's other symbol groups that we can choose too. Okay, there's a lot of different symbols up here, and I can just pick the symbol one, but it gets pretty messy if we do that. So we were under symbol math, and I can look and see if there's any symbols that represent the counterbore here. All right, I don't see any. So I'm going to have to go to, now the meteo is meteorological symbols, there's music symbols, there's system symbols, and then there's just the symbol option. I'm going to go ahead and choose just symbols because I believe I can find the counterbore under just the symbols. We got perpendicular right there, and we'll look down here. There's actually more symbols to look through. But there is a counterbore symbol in here, and I just have to find it. There. Okay, I was looking under the symbol, but realistically, I found it under the GD&T. So we have to scroll and find GDT as the symbol type. So that may be, since it's alphabetical, way up towards the top here. So there's the GD&T, and we find the counterbore symbol under GD&T. And so I can select the counterbore and copy it. And I can do a Control V in my text window here, and there's my counterbore symbol. And if we want to put it on the next line, I hit the Enter key, it can go on the next line. So counterbore, and the diameter is under the regular standard symbol, and diameter 28. The depth symbol is also a GD&T symbol. So we choose other, and then find GD&T again. And the depth symbol is, oh, where's the arrow down? Right here. That's the depth symbol. Select it, copy it, click back over in your text field, space, paste it, Control V, depth of 8. And so in essence, you just built your own dimension for the counterbore, and that takes care of this circle and this circle. Again, now that we set the scaling, the linear distance and so forth should be okay. Well, that was 50. Oh no, that needed to be 100, didn't it? Okay, so let's see. Let's make sure that this distance is appropriate. 8, that should have been 15. Well, we have an issue, don't we? So this needs to get stretched by 50%. Boy, I messed this up pretty well today on this drawing, but we can fix it. Alright, so here's what we have to do. We got to stretch it. So first things first, we use the stretch command. We pick a point on the outer edge here. Up, you can see where my box is. We come back in with the green window. That's the cutting window for stretch. So I just cut it through the middle. I right mouse click, pick an endpoint, and I'm going to stretch this to 100. Or I need to do a horizontal type of 50. So now it's 100 units, but these are still 8. No problem. We use stretch again. I'll use the green window on this back one here first. Pick the endpoint and notice that I'm only stretching the depth of the counterbore. And I need to make that 7 more, so it's 15. And I can do the same thing here with stretch. Oh, I just made that 107. We can stretch it the other way too. So I'm going to do stretch right here in the middle. Pick it and bring this horizontal 7 units. And I need to shrink this now from 107 to 100, so I'll use stretch again, outer edge, cut in the middle, right mouse click, pick an endpoint, and we're going to stretch this horizontally back 7. I know, a lot of stretching, but the stretch command works really well, and it's not hard to do using that crossing or the green window. And I can continue to put in my text dimensions here to show you that it is accurate now. Again, all the holes are set up over here on the left side view with it, and there we have that view. Again, LT scale, dimension scale, we showed you how to fix several things, the stretch command, symbols with the GD and T symbols. So we're all set. This hopefully will help you in your drawing environment in creating a sectioned drawing. Have a great day. Bye now.